Good. Alrighty, Algebra 2 folks, welcome back. So we said we were going to show you an example, and here we are going to do that.
We're here again.
Alrighty. So just remember, folks, we stopped at the end of the last video talking about what the domain and range were. Or actually, I think the last thing was a question about how do I know my graph is accurate. But you remember from the last video, the domain is just a set of values for our independent variable. Again, that's always graphed on the horizontal axis here. And then the range is all the set of values for our dependent variable, y. So I'm just going to label our axes here. My question for Mr. Chu here is just what are the domain and range of these graphs? And I realize now that you cannot possibly answer this question if the axes are not scaled. So let's just scale these right here. I apologize. That would be kind of mean. Alrighty, Mr. Chu, this first one here on the left side, how would you describe the domain and or range?
All right, it looks like the domain on the left one, we're looking at the x values for domain because that's an independent variable. So it looks like we're going from 2, but not including 2.
Oh, yeah, okay.
Go over to the right, we're going all the way to +1, and we're including +1.
Right, so this open dot filled in dot business is hopefully familiar from when we were talking about inequalities, right? And so we could denote what Mr. Chu said. We're going from negative 2, excuse me, but not including -2. And so the way we could write this is, I write D there for domain. Remember that the domain is the set of all things. And so we start off sets with these squiggly brackets. We were talking about our x values, so just a reminder to the reader, hey, we're looking at the x values. And this is where the new part is. This vertical line here just means, like in English, it just means such that. Such that. And so, sorry, Mr. Chu, could you just repeat? We want all the x's that are what?
Yeah, x was from -2, but not including -2 because of the open dot, and all the way to 1, including the 1 because it's a closed dot.
All right, and so the x values are everything in between those, not including, so that's why x here is greater than 2, but it could include 1, so that's why we have the less than or equal to 1. And similarly, our range, we're going to write it pretty much the same way, except R for range. And so where are we going on our range, Mr. Chu?
Okay, it looks like for the range, we're looking up and down on the y-axis. So it looks like we start at 0, right?
Yeah,
0,
right,
and it goes all the way up to, wait, not including 0 because the open dot, and then it goes up to 2 and including 2. So I guess you're going to write the range is the set of numbers y.
Yeah, what values?
Such that, right? Because that line you said is such that it's starts at 0. So 0, right? Less than y.
Yeah.
And then because it's a closed dot, it's less than or equal to 2.
Yeah. Nice, I like that. So notice here, folks, I tried to help you out by just drawing a little, you can kind of draw a box around your graph, as it were. And all you're doing really is I'm going to pull out my handy dandy ruler here. And what Mr. Chu was saying.
I don't have that on my
iPad.
Cool.
Everyone loves the ruler. Is that he's kind of taking or maybe taking your pencil and kind of scanning across. And what x values are being hit by the graph? Well, not 2, but now it is going and going. We're good. All the way up to 1. And we can do the same thing vertically to get our range. Starting off at 0, not including 0, and then just going up there. Alrighty. So now we got a spicier one, where this graph is kind of broken up into 2 pieces here. So Mr. Chu, you want to take a stab at this one?
All right. So there's 2 pieces. there's left piece and right piece.
Mm-hmm.
So it looks like, okay, let's do domain first.
Sure.
So for the x values on the left piece, it looks like it goes from -1 to 0. So you're probably going to write x such that, right, to
Yeah,
start that out
such
with.
that.
So we're going to go from -1 to, what did I say, 0? So
0, I believe. Yep.
yeah, and it looks like they're closed out, so it's, yeah, less than or equal to.
Yeah.
And I guess
Now.
the problem is there's a second chunk, right?
Mm-hmm.
So I think you could use a comma there. That's how I would do it, at least.
Yeah.
Right, comma. And there's another piece, and that's going to be from 1, not including 1.
Oops, sorry, pause this one.
And you have
Yeah, it's that
it's
fancy
kind
A
of
word.
spicy, Mr. Chang. Jeez. Okay, so you got an asymptote there, right? Asymptote.
Mm. Yeah, this dotted line here is an asymptote.
One S. I always mess it up. I always do two S's every year. It's
I
just
think a
one.
lot of people also forget the P as
Yeah.
well.
Asymptote. Okay, so it's asymptote, and that means that you're approaching that vertical line,
Mm-hmm.
but never getting to it. Like you're getting closer and
Right.
closer and closer. So
Mm-hmm.
it looks like you're going from 1 to 2, not including the 2 because we never hit it, and also not including
Right.
the 1 because it's an open dot.
Nice. Yeah. So that second chunk exists just between 1 and 2, getting super duper close to 1 and 2, but not actually hitting those points there, or
Yeah.
hitting those x values rather. And
Yeah.
the last one here, we just need the range now of our function here.
Okay, yeah, you're right. This is kind of spicy, right? Spicy because there's some overlap in this range. You can't fool
Mm.
me, Mr. Chang. Try to give me a spicy
Here,
problem.
I'll give you the ruler though.
Okay, yeah. So it goes from 2,
Okay.
including 2, and then like you go down and you're trying to like be real spicy here. You can't trick me there. Because, wait, back up a little bit. So you're at the 1, right?
Mm-hmm.
So the one's included because even though there's an open dot to the right, there's a closed dot on the left. So that's
Yeah, the
included. Okay.
graph. Yeah, the graph does exist on the left chunk, so we'll keep going.
Yeah. Okay. So you keep going. So I see why exists, and you could keep going on forever because there's an
Mm-hmm.
arrow. Okay. Yeah. So it is kind of spicy. And
Yeah,
yes, but I think you cannot fool me, Mr. Chang. Okay. It's
I tried.
the range is y such that, okay, you're going to start
Oh,
at,
sorry.
well, let's see. Well, actually, you're going to go from what? I mean, if I go from order, it's going to start from way down below negative infinity, right?
Oh, I
Oh,
guess.
well, I
Hmm.
don't have to write that. You could just write y is less than or equal to 2, right?
Yeah,
I was thinking you have to put like y is greater than negative infinity, but that's kind of like
yeah,
extra.
yeah, that'd be
That's
kind of
the best way
extra.
to tell
Yeah.
students
So
say
this
it's
one's
so extra, Mr. Chu. Yeah.
yeah. So this one, unlike the first one, where we could put a box around the whole graph. This one we can't because it goes down forever. So we would have to put our dotted line somewhere way down here. Um, but yeah, so all we know is that there is no minimum y value, but there is a maximum, and it's never going to go above 2. Alrighty, so thanks, Mr. Chu.
All
So
right.
hopefully, folks, this will help you, given any kind of graph, no matter how spicy it is or how extra it is, you'll be able to provide its domain and range.
All right. Thank you.